Hello, I'm Lord Tony, and today we're going to be learning about how to get Bad Apple, or any MP4 really, running in ASCII on a console in Linux. Now, I say in Linux, but really the only thing that's going to change between Linux and Windows is the calls you make in these OS system calls, but we'll get to that later in the video. So let's just jump right in. For the sake of speed, we're just going to be importing things, or I'm just going to be copy-pasting things right here. So first thing you want, if you want to be able to play an MP4 file in ASCII, you're going to need the MP4 file. So here I've got Bad Apple, the MP4, bad.mp4, and here we're going to use this as a source, and we're going to read this video, we're going to rip the sound out of it, we're going to do all that stuff, and we're going to convert it to ASCII and print it onto the screen. So let's just hop right into it, not waste any time. So the first two things you're going to need to do are import these libraries. Now, if they're not installed on your machine, which I don't think they are from the beginning, I mean, not like I know your machine, but if you just installed Python, these probably won't be there, and you'll have to use pip in order to install them. Just check that out online. I don't know, DuckDuckGo, Ask Jeeves, Lycos, whatever search engine you happen to be using. So we're going to import CV2, which I imagine stands for computer vision, and this will let us bring in the video file to where we can use it. And then the Python image library is used to take the individual frames from that video and mess with the pixels of them, like look at the pixels and use them to decide what ASCII character to print on the screen. So with those two things, I think that's most of what we'll need. The next thing is, you saw that video was called bad.mp4, so we need a path to that video file that we're going to be loading, no problem. And then we are going to use cv2.videoCapture and then pass in the path to our mp4 file. Now, I haven't tested this with other file types or other videos like AVI, but I imagine you could probably read lots of video file types with this. I don't think you're limited to just MP4. Well, you know, shoot me if I'm wrong. Leave a like on the video if I'm wrong. Okay, so the next thing we're going to do is just an infinite loop, where inside the infinite loop, we're going to read a frame off that video capture. So what's going to happen is it's going to run through here infinitely until it fails, and then the next time it tries to read, it'll basically throw a stack trace. So we're going to read this till we run out, or not a stack trace, an exception. We're going to read this until we run out of video frames, and then the program's just going to crash, which I think if you're running Linux, that's a fine way to end a program. It tells you if it's succeeded or not, but we're just going to ignore that variable for now. This is what we care about, the video frame. So now we're going to take that video frame, and we're going to use the Python image library to read the frame and get it into a form that we can now manipulate. So now we have all the info about the frame, and we can step through it pixel by pixel and start printing that to the screen, ASCII style. So first things first, if we're going to iterate through it all, we want to get the height and the width. So I'm pulling out size and I'm destructuring it into height and width, and start with the y coordinate. So the y-coordinate would be height, and the x-coordinate would be width. So now what we want to do is we want to look at the pixel at that given location for x and y. So we've got the x and y coordinate. Now we want to look at that location and start making decisions about the pixel. So this is how you do that. You've got your Python image library object for the image, and you call a getPixel method on it with a tuple as the argument with an x and y coordinate, and it will return you back the r value from 0 to 255, the g value, and the b value. That's red, blue, green. And, well, Bad Apple is basically just a black and white video, so RGB, they're probably going to be about the same for like every gray or white or black. But just so I can sleep at night, I'm going to convert these into one value here by just adding them all together and dividing by 3. And that'll just give us a value from 0 to 255. And from there, now we can actually start printing stuff to the screen. So let's just do this naively to start, using Python's awful ternary expression. So we're going to print out a hash symbol if the value is greater than 255, because that would mean it's leaning more on the white side, and else we'll just pass back a blank space. And so there, this will start printing stuff to the screen for every pixel and every frame of this video. But print also adds line enders, and we don't want a line ender for every row. I mean, for every column. So for this Python call, we'll set the end character from the default of a line break to absolutely nothing. So it'll just print these all next to each other. And then once we're done getting to the end of all the columns, we'll do a print so the next row can start. And that'll just print out a new line character. So now let's clear this out and start trying to run bad2. See how this goes. Bad2.py. Oh no. There. Okay, and I'm going to zoom out a little bit because the resolution is going to be really high. So you may be thinking that it's not working now, that we've frozen it up, but what's happening is Bad Apple has a bunch of black frames at the beginning, and then the video starts showing up here. So right off the bat, you can tell that we need to clear the screen for each frame, otherwise it's just going to be this slideshow. And then also, this frame rate is just unacceptably low. So let's start by cutting up these frames. So what we need to do is we need to be able to tell the console right here to clear frames when it needs to. And so for that, I'm going to need to import OS. And this will let us talk directly to the operating system. So before we start printing a frame, we'll just say OS and we'll make a system call. And then we will run this command right into the console. We'll do a clear command. So on Windows, it should just be CLS, and that'll do the same thing for clear screen. But for Linux, you run the clear command, and that should sort that bit out. Now let me zoom out again, because our resolution is huge. Is this working? Yeah, I see the cursor going back up to the top. Okay, there we go. It's blinking like crazy, but it is clearing the screen. We've got something that looks like a video here, but you're noticing that we're actually seeing it draw. This is so incredibly slow, it's unacceptable. So the way we can fix this is instead of doing a print for every single pixel in the screen, we can just build up some kind of buffer. We can call it buffer here. We'll start out with nothing, and then instead of just printing it out, we will just add on that buffer onto, we'll just add on the character that we want onto that buffer, and then instead of printing it here, we will add a new line character to the buffer, and then we'll just print it all once. So I got to move this system clear down there, otherwise that'll cause some problems. So at the very end, once we've got the entire buffer for the frame, we'll clear the last frame, and then we will print out this buffer. And actually, we don't even have to use print anymore. As long as we're already using the system call, why not just use the direct system call for this? We'll use those nice Python formats here. Okay, there we go. So now we clear the screen, and then we're going to call a system call to echo out whatever's in that buffer, which should be the ASCII for our frame. And this should run quite a bit faster. I'm not going to zoom in here, because I'm going to have to go out anyway. Is it working? It's hard to tell. Have I messed something up? Ah, I know what I've messed up. No, I haven't messed anything up. What have I done wrong here? This is the part of the video that fails every single time. Clear, comma, echo, buffer. Clear the last one, write the new one. Maybe, okay, this seems to be working. Maybe it really was just going through those black frames and it was rendering through the frames way too slow and I just wasn't patient enough. that has been known to happen. Yeah, here we go. So zooming out here. Okay, yeah, there we are. We've got rid of a lot of the problems. Now it prints all the frames at once. We don't see the cursor thing scrolling down to the bottom of the screen every time. It's actually looking pretty slick right now. The only thing is this frame rate is just unacceptable. And then also the aspect ratio is really tall. So let's mess around with that. So what we're going to do, since this doesn't look good as ASCII anyway, the resolution's way too high, is we're going to take steps over this whole thing. So we're going to take step sizes of 4. So basically we're only going to be trying to draw every 4th frame on the Y coordinate. We're going to be trying to draw every 4th pixel row and every 2nd column. So every 4th row and every 2nd column. That should speed up our frame rate by 8 times right there. So range has a few overloads for the method. So this is from 0 to height, step size 4. From 0 to width, step size 2. And this will improve our frame rate because we're only doing 1/8 the amount of calculations now. So let's try that again. Got to zoom in. What did I even call here? There we are. Yes. Okay. So already this is looking okay. We've got Bad Apple running on the screen, reasonable frame rate. Now, this frame rate is just all over the place. If your computer happens to be 10 times faster than mine, this video is going to be running 10 times faster. And you're also seeing a bit of a flicker there. Now, we can get rid of that flicker, and we will, because I actually have some extra time on this video. So we'll get rid of that flicker, and I think we'll fix the frame rate at like a locked-in 30 frames per second, because that's what the video runs at. But first of all, what has happened? Okay, so right now the problem is that it clears the screen, and then sometimes there's a split second before it actually prints it out. What I'm going to do is, instead of clearing the screen, I am going to do a different call here. I'm going to do a tput cup. I don't know why it's called tput cup, but what this is doing is saying, hey, just put the cursor back at 0, 0, and then when it does this echo call, boop. Okay, then when it does this echo call, what it's going to be doing is it's going to be writing over the last frame starting at 0, 0. So there's no point where the old frame is actually erased. So it just draws the new frame on top of the old frame instead of trying to erase it. And this will make it get rid of the flickering. There we are. So now no more flicker, nice stable-ish frame rate. But again, this just happens to look like the right frame rate. This is just however fast your computer ends up rendering it. Yeah, with that, we've basically succeeded. We've gotten Bad Apple running here on the screen, but there's no music right now. So one thing I'm going to do before we hit the 15-minute mark of this video is I'm going to go ahead and try to get, here, clear out that, clear. What I'm going to do is I'm going to try and get us some music going on here. I'm just going to steal this right from the old script. So another thing that you can do is the play sound library. And all that does is plays a sound. So I'm just going to take that play sound library, import the function play sound out of it, and then grab my audio file, which I've actually had to rip out of the MP4 file. Maybe this will take more than a minute. But yeah, here's the code I used to rip it out of the MP4 file. I basically take the audio name, I called it bad.mp3. Oh, gotta move it up here. Bad.mp3, because why not? And I have just ripped it out with some code I copy-pasted off the internet. So file video clip, I must have pulled that from another library. Where is that? From the Pi Movie Editor, another library I had to install. So here I say if the path doesn't exist, if there's no bad.mp3 in your file, then the first thing we do is we create a video clip with bad.mp4. We pull the audio out of it like that. We write an audio file, then we close both of those streams. So that's the heart and soul of it. And at the very beginning, okay, we can't play sound there. We play sound here. So this already, the MP3 file already exists on my computer, so it's not even going to run that code. It's going to find it and just drop it. But here, it's going to play that audio, and then this false means should it do it on the same thread. I'm saying false because I want this to run at the same time as this code that's running below it. So it's just going to start playing, and then it's going to relinquish control of the thread onto my rest of my code. If you don't put anything, this sound will play, and then it'll stop, and then the video will play, which isn't what you want always when it comes to syncing up videos. So let's see some Bad Apple with sound now. There we are. What a work of art. The only problem with this is now eventually the sound is just going to either outpace or be slower than the video. Yeah, that break is supposed to hit right when she grabs the apple. So we'll fix that up next time. But for now, this has been Lord Tony. Thank you for watching.